Okay, so what if we could fight a disease that targets the old, like Alzheimer's, by using a secret weapon from the young? It sounds like science fiction, right? But a brand new study might have found the key. And honestly, it could completely flip what we think we know about aging and the brain.
I mean, this is one of the biggest questions in medicine today, isn't it? For decades, we've struggled with treatments for conditions like Alzheimer's. Most of them, they just slow the decline. They don't stop it. But what if? What if that decline wasn't a one-way street? What if you could actually turn back the clock? Well, it turns out some researchers in China have just published findings that give us a pretty startling hint. A clue that suggests, yeah, maybe we can reverse some of the damage that comes with brain aging.
All right, so to really get what they did, we need to connect a couple of dots. Fact one, Alzheimer's is at its core a disease of aging. And fact two, as we get older, our immune systems, well, they just don't work as well. So that led these scientists to a really radical question. What if a younger, more powerful immune system could actually help an older brain? And the potential answer? It's hiding deep inside our bones. We're talking about these incredible cells called hematopoietic stem cells, or HSCs for short. The easiest way to think of them is like the master factory for your whole immune system. They're the ones pumping out every single type of blood cell you need to fight off anything and everything. They're absolutely crucial. But that factory, it doesn't run at full steam forever. Just like everything else in our bodies, our immune system ages. And that whole aging process, it really starts right there, with those master stem cells. And when you look at the difference, it's pretty stark. In young bone marrow, you've got this huge diversity of stem cells. It's like having a giant, fully stocked toolkit, right? You've got the right tool for any job, creating this super robust, flexible immune response. But as we get older, that diversity just plummets. Suddenly, it's like you're trying to fix a spaceship with just a hammer and a roll of duct tape. So there's a scientific name for this: clonal hematopoiesis. All it really means is that a few types of stem cells start to take over, they dominate, and just crowd out all the others. And that collapse in diversity, that's a huge reason our immune system gets weaker as we age, and it's exactly what these researchers decided to go after. So with this problem squarely in their sights, a team in China set up a pretty bold experiment. They took mice that were genetically engineered to mimic Alzheimer's disease, and they used them to test a really radical idea. The setup itself was actually super simple, which is what makes it so brilliant. They took older mice, 9 months old, that had all the signs of Alzheimer's. One group, the treatment group, got a bone marrow transplant from young, healthy 2-month-old mice. Then you have the control group. They got a transplant too, but from mice their own age. So, you see? The only thing that was different was the age of the immune system they received. So the big question was, could this young immune system really do anything for an old brain? And the results? Well, to say they were astonishing is frankly an understatement. Okay, get this. The mice that got the young bone marrow showed just dramatic improvements. The toxic gunk in their brains, those amyloid beta plaques, they were significantly reduced. Brain inflammation, it went down. The rate of brain cells dying, it slowed. And the craziest part? Their memory and their ability to learn actually got better. So how on earth did this work? Well, the young bone marrow essentially rebooted the whole immune system in the older mice. It was like it built a fresh army of immune cells, specifically these guys called monocytes, that literally traveled to the brain and started clearing out all those toxic plaques. It's like they called in a brand new, super effective cleanup crew. So that's it, right? Case closed. We've found the cure for Alzheimer's? Well, not so fast. This is the point where these incredible, almost miraculous results run smack into a very, very serious real-world problem. Yeah, this is the multi-billion-dollar question, isn't it? After seeing this in mice, of course the next step is to ask, can we do this for humans? But the ethical questions that come with that, they are just staggering. Dr. Zachary Harvanek over at Yale put it perfectly. He said this whole idea conjures up dystopian future images of billionaire vampires obtaining young blood to keep themselves young. And he's right. It immediately brings up these huge concerns about fairness and exploitation. It paints this really ugly picture where only the super wealthy can afford to buy youth. Thankfully, the scientific community is already way ahead of this. They're not actually focused on that dystopian scenario. Instead, they're already hard at work looking for smarter and much more ethical ways to get the same incredible benefits. And the good news is there are other paths forward. For example, you could bank your own marrow when you're young and then use it later in life. That's one option. But an even better idea would be to figure out what the exact anti-aging stuff is in young blood and just make it in a lab. The holy grail really is to develop a treatment, maybe even just a pill, that gives you all the benefits without needing a transplant from anyone, ever.
And that, right there, is the real promise of this research. By going after these smarter alternatives, science could harness the power of a young immune system in a way that's safe, ethical, and, most importantly, accessible to everyone, not just the person with the biggest bank account.
So, this incredible research leaves us with a really fascinating question for the future. As we keep unlocking the secrets of aging, is the answer going to be a major transplant? Or could it be as simple as a pill? The path we choose isn't just going to define the future of medicine. It might just define the future of what it means to grow old.